Good morning, sir. My name is Crizilin A. Cabio from Bachelor of Technological Education, major in Computer Technology. So my topic is all about bending sheet metal by hand. Specific learning outcomes. At the end of this lesson, students will be able to first identify the different types of sheet metal, second, to know the bending process, third, show their own understanding on how to prepare sheet metal with a vise, fourth, give an example of Hans Zimmer's, fifth, identify the three different types of bends in sheet metal, and the last one is learn how to bend sheet metal using by hand. What is bending sheet of metal? Metal bending is a process by which metal can be deformed when applying force to the subject, which causes it to bend at an angle and form the anticipated shape, which often result in it being in a V or a U shape. A press brake is a tool used in order to bend sheet metal and uses a punch and die to do this. Types of bends. So there are three types of bends used to form metal that any sheet metal engineer or press brake operator must be familiar with. First, air bending. Second, bottom bending, and coining. Air bending, also known as free bending. So it is the most common way for bending sheet metal because of its flexibility. So in air bending, a bend angle is formed by driving the punch into the sheet metal to a specific position within the die opening. Bottom bending, also known as bottoming. It is a bending process in which sheet metal is pressed against a bottom die featuring a V shape. It's often preferred over air bending because of its higher level of accuracy as well as less recoil with the finished sheet metal. Coining is a form of precision stamping in which a workpiece is subjected to a sufficiently high stress to induce plastic flow on the surface of the material. A beneficial feature is that in some metals, the plastic flow reduces surface grain size and work hardens the surface, while the material deeper in the part retains its toughness and ductility. So how is sheet metal bending done? Metal bending is a process by which metal can be deformed when applying force to the subject, which causes it to bend at an angle and form the anticipated shape, which often results in it being in a V or a U shape. A press brake is a tool used in order to bend sheet metal, and I uses punch, and die to do this. How do you bend sheet metal by hand? Most frequently, expensive sheet metal bending tools called brakes are used to break metal, but you can also complete this task with one. Bending sheet metal by hand is a manageable task if the piece of sheet metal is small and thin enough to handle. Bending a sheet with a hand seamers. A hand seamer seems to have just one purpose, to bend sheet metal. Something so basic, like most other tools, may be split down into specific styles based on the application. With this in mind, what exactly are hand seamers? For producing clean and exact angle bends in sheet metal, a hand metal seamer is suitable. The metal seamer has a sturdy aluminum structure and comfortable vinyl grips for use in most common tasks. Sheet metal may be bent, seamed, or flattened. Aluminum structures for long-term use. So how to bend using hand seamers? Hand seamers have jaws that are bent or offset. The reason for this lies with one standard use of hand seamers, which is to start or finish a seam in a piece of sheet metal, joining it to another panel on a sheet metal roof. So there are many different types of seams that can be used to join panels of sheet metal together on or off a roof. Malco hand seamers with forged steel jaws are the premier choice for bending, folding, flattening, and straightening sheet metal edges, or safely gripping and moving sheet metal around the job site. These seamers are available in 3-inch or 76.2 millimeters and 6-inch or 152.4 millimeter jaw widths, as well as an offset 3-inch or 76.2 millimeter size for overhead work that drop, forge, high impact jaws feature depth markings graduated in 1/4 inch or 6.35 millimeters increments and are complemented by a powerful compound leverage designed and easily bent flanges or completely flattened seams from 1/4 to 1 1/4 inch or 6.35 or 31.75 millimeters deep in 24 gauge or 0.71 millimeters galvanized or 0.61 millimeters milled steel. Preparing to bend sheet metal with a vise. Gather your materials. Having the right tools on hand will help this process go smoothly and quickly. To bend sheet your metal with a vise and a hammer, you will need two wooden or metal form blocks, block of hardwood and heavy-duty hammer or mallet, calculator or online bend calculator, marker, protractor, rubber, plastic or rawhide mallet, roller or tape measure, machinist vise. Preparing to bend sheet metal with a vise. First is to determine the thickness of your sheet. You can use a tape measure or roller to measure the thickness of your sheet metal. This measurement is necessary for calculating your bend allowance. Second is calculate your bend allowance. The bending you will be doing will warp your sheet metal so that it is physically bigger. You can find your bend allowance with the following formula. Bend allowance where is B is angle complementary to your desired bend angle and MT is the thickness of the material, IR is the inside radius and K is the K factor. Preparing to bend sheet metal with a vise. First is mark your bend lines. Now that you know your bend allowance, take your protractor and draw a clear line with your marker across the point at which you will bend your sheet metal. Second is cut your sheet size. You should leave a little trim to your sheet, approximately 1/4 is recommended. Be sure your file and smooth your sheet as nicks and rough edges can cause cracks to form into your metal. Bending your sheet metal with a vise. First is to place your forms in your vise. Your forms will have an edge that should match the angle of your desired bend. Situate your forms in the vise with a form block guide angle facing upwards out of your vise. One edge of your form will typically be rounded to the degree of your bend radius, thus helping you achieve your desired bend. Clamp your sheet metal in your vise. Now that your forms are placed, you should clamp your sheet between your form blocks very firmly and take care to keep your bend line even with the guide angle of your forms. Support your excess sheet metal. If you have sheet metal hanging a considerable distance outside of your form blocks, you will need to support this segment so that it does not bounce too widely and negatively impact your bend. Consider having a friend or a colleague stabilize this piece with their hand. Be sure to wear gloves to prevent any accidental cuts. Bend the metal with your mallet. To prevent damage or unsightly dents, it's best to use a rubber, plastic, or rawhide mallet to gently tap the metal. Do this until it bends towards the form block and achieves your desired angle gradually and evenly. Your tapping should start at one end of the evolving belt. Slowly work back and forth between your bend lines until the sheet metal is bent to desired angle. Troubleshooting the bending process. Verify the value for material thickness in your bend allowance calculation. So this particular value is deceptively named and contrary to the first impression, this number must be expressed as decimal for your calculation to be correct and it is based off of the standard gauge thickness. Double check your bend angle. If your bend allowance calculation seems off, a likely place you have made a mistake is with your bend angle. So if you are attempting to bend at an angle less or greater than 90 degrees, it is necessary that you take the complementary angle to that of your desired bend. For example, if your desired bend is 45 degrees, You will subtract this number from 180 degrees, which will give you a bend angle of 135 degrees. Adjust your vise. The pressure you will be applying to bend your sheet metal will be significant. So if you do not have a vise up to the challenge, if you do not have secured your vise sufficiently, your forms may slip, or you may bend your sheet metal in a way you hadn't intended. Apply heat for difficult bends. This should be done with extreme caution and care. In the event that you are bending a thick piece of sheet metal, you can apply heat from a blowtorch along the seam of your bend line to facilitate your bend. Keep in mind that many kinds of fabricated metal have extremely high melting points, and applying your torch injudiciously could cause damage or do harm to your sheet metal or equipment. So that would be all, and today I will show the video application about my report.
Sheet metal brakes are sometimes huge machines that are not always portable or affordable. So let's look at some other methods to bend sheet metal without a brake. This is Kossoro Jonathan here. If you ask most people how to bend sheet metal, they'll say that you need a brake. And that's not the one that you sit down and drink a refreshing beverage of choice. They're talking about a pan brake, a press brake, or a metal folding machine, which in this case I'm going to do without. I'm going to do it by hand or with minimal tools. But before we start, I'm going to answer a few questions and tell you a few things to consider when bending sheet metal. So what is a good bend? A good bend is defined by the radius of the bend, how straight it is, and if it meets the required angle. In this case, I'll be clamping the steel sheet and bending it. In order to make a bend that's as tight and sharp as possible, I need to look at the radius of the bend. The bend is always rounded, and the radius is the determining factor of how tight or sharp the bend is. And the radius of the bend highly depends on the clamping material. Timber is not hard enough to make a tight bend, and I require something harder, like steel. The inner radius of the bend is dependent on the radius of the clamping material, and the outside radius is equal to the clamping material plus the thickness of the sheet metal being bent. So a piece of angled steel with a sharp edge is ideal for a 90-degree bend. This might be common sense, but before you touch anything, consider safety. Sheet metal can be sharp, cause permanent injury, so think about protecting yourself because life is harder without your fingers, your eyes, or your blood. I'm going to bend 0.55mm zinc loomed steel sheet, which is roughly double the minimum thickness of this type of product, and it's about as thick as I would want to go by hand. Therefore, it should be a good measure of the different methods of bending thinner sheet metal. Okay, marking up. Marking up is essential because I need to know where my bend is going to be. I draw a line with a marker in each of the places I wish to bend. Paying attention to the edge of the line as an absolute measure where I intend the inner radius of the bend to be as close to zero as possible. Because each of the methods are based on force, I need to clamp this well. I sandwich the steel sheet between a rectangular tube and rigid angle, which are both longer than the sheet that I wish to bend, at the same time lining up the edge of my markings. I make sure that the two clamps are over the steel sheet but not interfering with the direction of the bend. Okay, let's start bending some metal. Method number 1, by hand. With everything clamped tightly, I get a good grip, and from as close to the intended bend as possible, I push upwards, refining the bend and lowering the position of the push until I physically can't push it anymore. I unclamp and refine the bend. It's not perfect, but the job is done. Method number 2, with a hammer. With everything clamped, I give a good push by hand like the first method. Then on the bend, I give it a soft hammer, slowly refining the edge, moving along the bend, trying to keep the hammer hits as tidy as possible. It has a few dents in it here and there, but it's definitely a tight edge. Method number 3, score and bend. So I put down a flexible material that will give a little during scoring. I put the sheet metal on top, then a rigid straight edge, and I clamp it down, leaving enough room between the line and the straight edge to accommodate a scoring tool. In this case, I'm using a screwdriver because the steel on the screwdriver is harder than the sheet metal. I score the sheet metal in multiple passes to get a score that's close to quarter thickness of the sheet metal. I want to make a weakened line where the bend favors that point, but not significant enough to compromise the strength of the sheet. Then I clamp it the same as the others, and I push by hand as close to the intended bend as possible. I refine, and then it's done. Method number 4, with the roller. For this one, I need to make a tool. I need a couple of trolley wheels and a bit of timber. The trolley wheels should be plastic or hard rubber. They should be square on the edge and rounded in the middle for the best performance. And simply, I'll pre-drill and screw them to the timber in an inline configuration. With the sheet metal clamped, I help it a little with my hand due to the thickness of the sheet. Then I roll the roller as close to the intended bend as possible. The roller works by pushing on a small area like the hammer. However, it doesn't dent and warp the metal quite as much. I continue to refine until the bend is sufficient. And once again, it's done. Okay, evaluation time. Personally, I think each of these methods have a purpose. I would bend by hand if that were my only choice and a sharp radius isn't absolutely necessary. I would use a hammer if I wanted a really tight bend, but I had time to refine the surface afterwards. I would score and bend if I wanted to control a long hand bend, but I didn't have a roller or the material was too thick, providing that I could protect the score mark from corrosion. And I would use a roller if I was working with thinner sheet that was going to be used externally. But which is best really depends on the situation and the operator. Working with metal can be tricky, especially if it needs to be precise. Metal remembers all your mistakes and doesn't easily forgive, but with practice, it becomes predictable. And if any of these methods were useful to you, please like and subscribe. And keep watching if you want to see bigger projects where we put all of this together. If you want me to go into more detail or make a video about something else, just drop a comment below. And remember guys, break it till you make it. And I'll see you next time.
Malco Products manufactures quality tools for professionals. We make the right tools for crimping, bending, folding, or seaming metal. Top quality products that work hard, enhance performance, and stand up to years of use on the job. At Malco, we believe in American-made tools that work, perform, outlast. Malco hand seamers with powerful forged steel jaws are the premier choice for bending, folding, flattening, and straightening sheet metal edges, or safely gripping and moving sheet metal around the job site. They're available in 3-inch and 6-inch jaw widths and an offset 3-inch size for overhead work. The drop-forged high-impact jaws feature depth markings graduated in quarter-inch increments and a powerful compound leverage design. Easily bend flanges or completely flattened seams from 1/4 inch to 1 1/4 inches deep in 24-gauge galvanized or mild steel. They also feature ergonomic redline handle technology. An engineered handle opening complements the natural power stroke of any user's hand and maximizes the powerful 7-to-1 mechanical advantage of compound leverage head-to-handle linkage. Natural handle grip contours, non-slip grip insert, spring handle actuation, and a thumb-operated handle latch ensure a natural fit and feel for comfortable one-hand operation anywhere on the job. Malco continues its tradition of quality and innovation, manufacturing hundreds of products from its Annandale, Minnesota headquarters to trade professionals in the United States and around the world. Malco Products, a proud heritage for a promising future.